BBC interviewer asked Alan Turing, "When do you think machines that can convincingly imitate human behavior will exist?" And he said, "Not for 100 years." In 1952, he predicted that until 2052, contrary to popular belief, we would have no way to closely imitate human intelligence. The second question asked by the BBC interviewer was, how would you develop such machines? And amazingly, he came up with a multi-part process. He said, "We will have to train these systems like we train our children," so he called them child machines. Alan Turing wasn't the only one to ask whether a machine could model intelligent life. In 1951, Marvin Minsky, who was a graduate student at the California Institute of Technology, collaborated with Dean Edmonds, a fellow student, to develop a pioneering computer system that simulated a rat navigating a 4x4 maze to find cheese. This is particularly interesting because, in 1951, semiconductors had not yet been developed. As a result, computers were constructed using vacuum tubes or valves. The term AI was coined by John McCarthy, and the period between 1950 and 1970 saw the emergence of numerous foundational areas of AI, driven by widespread excitement in the field. Arthur Samuel formally defined machine learning as the study that gives computers the ability to program themselves without being explicitly programmed by humans. Now, how does it happen? Suppose you're given 1 million pictures of cat and dog faces, and your task is to sort them into two groups, one for dogs and the other for cats. You could ask a 5-year-old child who would simply say, "This is a dog," or "This is a cat," and place them into the correct groups. But there is another way of doing this. A computer scientist could collaborate with a subject matter expert, someone who understands the differences between the faces of cats and dogs. For instance, cats typically have whiskers and raised ears, while dogs often have droopy ears. The computer scientist takes those features into account and writes a black box algorithm to distinguish between the two groups. The first input comes in, the face of a cat, and the output also displays face of a cat, and the 5-year-old child agrees. Here the error is 0 and the system does not modify itself. The next input comes in, it's a face of a dog, but the system identifies it as a cat, and the child disagrees. This error requires the black box algorithm to alter itself so that it correctly displays face of a dog. This process continues for about 10,000 pictures. If the algorithm is well designed and the key characteristics of dogs and cats are used, then it can achieve an accuracy of around 80% to 90% in distinguishing between their faces. This process is what we now call unsupervised machine learning, which was at the core of Alan Turing's vision for child machines. Systems that could learn and grow without direct instruction. Turing's ideas laid the groundwork for much of the AI we see today.